Hello once again. As we discussed in our previous video, what PMFs are or what probability mass functions are, we are going to solve examples concerning probability mass functions. And please, if you find difficulties understanding this session, I would like you to refer to our previous video titled Random Variables to be able to get a fair understanding of what we are doing here. So looking at this question, it is saying a manufacturer manufacturing produces metal bolts. The number of defective bolts found in a randomly selected batch of 4 bolts is recorded. Let X denote the number of defective bolts in the batch. Assume that each bolt has a probability of 0.2 being defective and that the bolts are independent. I. State whether X is a discrete or continuous variable. II. List the possible values of X. And III. Determine the probability mass function into bracket PMF of X. And IV, which is our last question. Find the probability of X less than or equal to 1. So you can see that here they are dealing with 4 outcomes and they are dealing with 4 bolts. So it can either be 1, 2, 3, or 4. So you see our events are finite. So they are asking us to state whether X is a discrete or continuous variable. So pertaining this question, we know that what? For I, our X is a discrete random variable. So our X is a discrete random variable. That means our X cannot take any value at all. It has to take values within the range that has been given in the question. So our II is saying list the possible values of X. So we see that X is just to represent numerically the probability of finding a defective bolt out of 4 defective bolts. So we see that our X, for II, our X can take values like 0, 1, 2, 3, and 4. These are the possible values X can take. And why is X taking 0? X is taking 0 because for a given set of 4 bolts, there might be no defective variable. So when 4 bolts are selected at random and there's no defective bolt, we consider it as what? 0. And when 4 bolts are selected at random and only 1 bolt is defective, the value of X there is 1. And when 4 bolts are selected at random and 2 bolts are defective, X is 2, 3, and 4 in order. So the values of the discrete random variables are 0, 1, 2, 3, and 4. So you see that it was telling us here that the probability that a bolt is defective is what? 0.2. So we have to take note of this 0.2. So they are telling us that determine the probability mass function. So I earlier on explained that the probability mass function is based on us knowing the values of X and finding the probabilities of those specific values of X. So for this table, we will have X here and we have our probability of X. So we know that the values of X, as we earlier on said, are 0, 1, 2, 3, and what? 4. So these are our possible values. So we know that our sample space is what? 4. And we've been given probabilities. So that means the probability that a randomly selected set of 4 bolts has no defective bolt is 0.2. And the probability that a randomly selected 4 bolts has only 1 defective is 0.2, 0.2, 0.2, and 0.2, as it has been said in the question. So this is simply the probability mass function of the question that is stated above. So this probability mass function just tells us that for a random variable assigned with the value of 0, the probability of getting 0 defective bolts is 0.2. That is the same as 1 over 5. The probability of us getting 1 defective bolt is also 0.2. The probability of us getting 2 defective bolts out of 4 is 0.2. The probability of us getting 3 defective bolts is 0.2, and so on. So this is the solution for III. But let's verify if we are actually correct. And in our previous video we discussed the definitions of a PMF. And we said that for a PMF, all the probabilities, the probability of all x should be greater than or equal to 0 for all values of x. So for this condition, all the probabilities here should be greater than or equal to 0. And we see from 1, 2, 3, 4, and 5, all the probabilities there are greater than 0 for all values of what? X. Let's now go to what? The second definition of a PMF. The second definition of a PMF tells us what? The sum of all the probabilities should be equal to 1. So we see that here we have what? 5 events. 1, 2, 3, 4, 5. So here we have 0.2 plus 0.2 plus 0.2 plus 0.2 plus 0.2. When you add 0.2 5 times, you get what? 1. So this is telling us that what? Our solution is correct because it satisfies all the conditions for a particular function to be a probability mass function. So they are telling us that find the probability of x less than or equal to 1. So for x less than or equal to 1, we just come to this table. It is simple. That means less than or equal to 1, it can range from 0 and 1. So these are the two values we are looking for. So probability, they are simply asking us to find the probability that no bolt was defective and the probability that what? One bolt was defective. So the probability of x is less than or equal to 1 is simply adding this and this. So that means it is probability of x less than or equal to 1 is equal to what? Probability of x equal to 0 plus probability of x equal to 1. So probability of x is less than or equal to 1 is equal to, what is our probability of x equal to 0? We have 0.2 plus our probability of x equal to 1. We have what? 0.2. That will give us what? 0.4, which is the same as, yes. So this is the probability that x is less than or equal to 1. That means we are considering x being equal to 0 and x being equal to 1. So this is just a typical practical example of how a PMF question looks like. Thank you for your time. See you next time.